Good morning, boys and girls. Today I'd like to talk to you about how we can create an algebraic equation just by looking at a graph. So let's start by looking at a graph. Here's a graph that I created. Its title is Distance Remaining While Flying in a Helicopter from New Jersey to South Carolina. If you look along the x-axis, you'll see that it takes about 6 hours to fly from New Jersey to South Carolina. And if you look along the y-axis, it's about 600 miles between New Jersey and South Carolina. The x-axis, the number of hours, can be thought of as the independent variable. An independent variable does not depend upon anything else. An hour is an hour. Whether you're eating or sleeping or studying for math, an hour does not matter what you're doing. The number of miles remaining is a dependent variable. The number of miles remaining does depend on how long you're in the helicopter. If you're flying for just 1 hour, you have a lot of miles left for traveling. But if you've been in the helicopter flying for 5 hours, then the number of miles is very small. You have almost reached your destination. So dependent variables depend on other values. Now that we've explored the parts of our graph, we need to really understand the data that's found in it. We might want to start with a little data table. If we create an XY chart or a data table with our X and Y values, I think you'll find there's a lot of patterns that we'll see. Let's start when X is 0. When we haven't flown any time at all, how many miles are remaining? Well, when X is 0, Y is 600. Let's keep going. When X is 1, the value for Y is 500. When X is 2, the value for Y is 400. When we have traveled for 3 hours, we have traveled for 300 miles. We're halfway there. You might already notice some patterns with our data, but let's keep going. After 4 hours, there's 200 miles left to go. After 5 hours, just 100 miles to go. And after 6 hours, 0 miles, we have reached South Carolina in our helicopter. Now that we have our data in a table, you might see a lot of patterns. I notice that my values for X are getting larger and larger by a value of 1. So the increment is just 1 each time. While if I look at my Y values, the numbers are decreasing from 600 to 500 to 400, 300. Do you notice a pattern? We can use the patterns from our data table to help create an equation for this line. Normally, when we write equations for lines, we start with Y. So we'll start with the dependent variable. In this case, Y equals, look at the Y's. Y's equal 600, 500, 400. Well, they start at 600 and they get smaller and smaller and smaller until it's 0. Let's start with 600 minus. This is definitely going to be a subtraction problem. How much are we subtracting? If I look again, I see 600 down to 500, down to 400. I know that I am decreasing in value by 100 each time. So the 100 is going to be a part of this equation. So I take the largest value of Y, which was 600, and because my line is going down, down, down to 0, I know it's going to be subtraction, and each time it's going down by 100. Ah, I forgot my x. Yes, I need to add my x in there. My equation is y equals 600 minus 100x. Let's see if this tests out. Let's use the equation y equals 600 minus 100x and evaluate it for each value. And we'll start with 0. When x is 0, what will y equal? Well, 100 times 0 is 0. 600 minus 0 is 600, so that tests out. That is correct. Let's substitute in 1 for the value of x. When I substitute in the value of 1 for x, then I have to multiply 100 times 1, that's 100. 600 minus 100 is 500. Good, that works. I'm going to check all of my data points just to make sure my equation is always true for all values of x. So when x is 2, that's 600 minus 200 is 400. That checks with my value from my data table. Now I'll substitute in 3. When x is 3, that's 600 minus 300. Check. That works. And I'll continue with each and every value for x. When x is 4, yep, that works. And when x is 5, yep, that works too. One more to check. When x is 6, 100 times 6 is 600, and 600 minus 600 is 0. Perfect. So I was right. The equation y equals 600 minus 100x is the equation that defines that line. I started with my largest y value. I used subtraction because the y values were getting smaller and smaller and smaller each time, and I had to think about how they were getting smaller. They were getting smaller by 100 each time. So for each hour, they were decreasing the number of miles remaining by 100. Boys and girls, this is a very tricky procedure. Please practice it. If you need to watch this video again, pause it if it helps. Please, I want you to understand this basic way to form an equation because they will get trickier. We know that lines might go up, they might go down, they may go left to right. And next year you'll find there are equations for circles and for other shapes. So please practice this and understand the basics, and I'll see you in class. Bye-bye.